Oh, didn't see you there.
What are you doing, Bill?
Nothing, just preparing for my experiment on covalent molecular solids.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science. Bill Nye the Science.
So let's take a look at how covalent bonds are formed. So if we were to draw one, we would notice that in order to bond nitrogen with hydrogen, we would need to have a bond between here and here and here. And if we wanted a hydrogen bonding, we have one here, and we have C here, and we have an H here, H here, and H here, and we have hydrogen bonds here. And then we have another one here, another one here, another one here, another one here, and oh, we have hydrogen bonding. And then we have chlorine over here, and then we have chlorine, and we have chlorine, and we have chlorine, and then down here, and then we have another one over here, and then and then go here, and then go oh over here, we have H, we have C, we have oh, and roll to the next cup. Roll to the next cup. Now, a covalent bond is formed when two atoms share electrons in order to become stable. An atom is stable when it has a complete valence shell. However, only nonmetals can form covalent bonds, such as chlorine, fluorine, oxygen, nitrogen, carbon, and the list goes on. Covalent molecules are several covalent bonds come together to form a complex structure.
Hey, Bill, can sodium form a covalent bond?
Nah, only nonmetals can. Didn't you listen? But do you really know how it works? Well, let's find out.
Lonely, I'm Mr. Lonely. I have nobody for my own. I'm so lonely. I'm Mr. Lonely. I have nobody for my own. I'm so lonely.
Molecular solids are held together by van der Waals forces, also known as London dispersion. These forces are relatively weaker than ionic bonds. Because they're weaker than ionic bonds, molecular solids tend to be soft. They're also poor conductors of heat and electricity, and are non-electrolytes. Do you know why?
Oh, I know. Molecular substances won't conduct electricity because even in cases where electrons may be delocalized within a particular molecule, there's insufficient contact between the molecules to allow the electrons to move through the whole solid or liquid.
In simpler terms, molecular solids don't conduct electricity. But they do, however, have really low boiling and melting points. So let's find out.
So, here is a sample of sugar, and here is a sample of salt. Now, as we all know, you can melt sugar to form sugar syrup, to form caramel, but have you ever heard of melting salt?
No, that's because salt's ionic, and ionic bonds are a lot stronger than van der Waals forces.
Exactly. That means that ionic solids, such as salt, would have a way higher melting point than a covalent or molecular solid like sugar. As you can see, the sugar changed its state to liquid, whereas the salt is still a solid. This experiment proves that sugar has a lower melting point due to the weak dipole-dipole forces that hold it together. Now that we have a basic understanding of what covalent bonds and molecular solids are, let's make some real-life connections. As we already mentioned, sugar is a molecular solid, so is solid carbon dioxide. And there's another one. Let's see. And then it hit me! Ice!
If the formula for water is H2O, is the formula for ice H2O cubed?
Why, yes it is.
Well, that's it for molecular solids. Tune in next time for a segment on covalent network.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill the science. Bill Nye the Science Guy.